Let's see how to enter screws in CYPE Connect to thereby solve the connection between two timber elements. To do this, starting from a previously created node, we select it in the table on the left-hand side of the interface and edit the connection by clicking on the corresponding button at the top. In the Connection pop-up window in the Model tab, we must specify the operations needed to define the connection. The example shown here has a plate entered on the main beam B1, with a second plate added perpendicularly and welded to the first one, connected to beam B2 with bolts. We are now going to enter the screws that allow the connection between the first plate and the main beam B1 to be solved. We then proceed by opening the Timber menu in the top toolbar and click on the Screws option. First of all, we select the elements connected by the screw. The steel element can be either a section or a plate. In this case, we choose plate 1. Then we select the timber element, that is, beam B1. Below is the table where we define the number and position of the screws. If we wish to define the position of the screws manually, we click on Add and enter their X and Y coordinates with respect to the local coordinate origin of the element. With the tools at the top, we can copy, delete, move, or delete all the elements in the table. We also have a tool to generate screws automatically. The help image that appears when clicking on it shows the local axes of the element, with the x-axis in red and the y-axis in green. In this case, we define 2 rows and 6 columns of screws. We then type in the initial spacing of the rows and columns with the element edges, as well as the spacing between rows and columns. By clicking on Accept, the screws appear in the table, where we can modify their coordinates if necessary. After this, we define the type of screw. By clicking on the button on the right, we can select the series, the nominal diameter, and the length from those available. Then we click on Accept. If desired, we can select the button with the name of the series and the diameter to modify their properties in the pop-up window. 2 of them can be found at the top under the series and nominal diameter references. We can also modify the smooth shank diameter, inner diameter, and outer diameter measured on the threaded part, as well as the length and length of the threaded part. At the bottom, we can define the countersunk part of the head, the external part of the head, and the washer, and enter parameters such as the diameter of the external part of the head and the thickness of the external part of the head for each of them. In the following section, we indicate the screw's material. In the same way, by selecting the button on the right, we can select a material from those available and then click Accept. By clicking on the button with the material name, a window appears where we can modify its reference, description, modulus of elasticity, yield strength, and fracture limit in the window that appears. Further on, we define the space between the screw and the steel element. Finally, by activating the last box, we indicate the data of the pre-drilled holes. In this case, we type in the diameter of the lead hole for the shank, the depth of the lead hole for the shank, and the diameter of the lead hole for the threaded portion. From this point, once the model is finished, we can continue our work by carrying out the analysis from the corresponding tab.